Hi, everyone, and welcome to your first somewhat live lesson for Module 1. This is Lesson 2, and we're going to talk about measurements. We're going to talk about Sig Figs. We're going to talk about dimensional analysis. Now, this is something that we're going to use throughout the year, and so these things are really foundational to what we're going to be doing in this class. So it's really important that you understand how this works. With your online course, remember, you can pause this video whenever you feel like it. You can stop, you can rewind, you can do what you need. You don't have to sit and listen through the whole thing. Go write down a question, come ask me, send an email, put it in the discussion board. There's lots of different things. So if you need to break it up, please do. And please ask whatever questions that you have. So we'll just start here talking about measurement. So when we talk about measurements in chemistry, when we get into the lab, there are lots of different measurements that we're going to take. And it's important that not only does the measurement have a number, obviously, but it needs to have a unit. For example, look at that box. That box weighs 25. 25 what? Is it 25 pounds? Is it 25 grams? Is it 25 ounces? So all of those things are a lot different, okay? And so we need to specify. Now, there are an international system of units called the SI units that are used in science and that are used across the world, just so things are more standardized. The international system of units, so the SI unit for mass is going to be kilogram, abbreviated kg. Length is in meter, just m. Time is in seconds, which is just an S. You're going to see me write SEC a lot because, I have to do it my own way. Quantity is a mole, abbreviated, not much of an abbreviation, but MOL. And then temperature is going to be Kelvin, which is just a capital K, no degree symbol. I'm sure you've seen Kelvin before. The mole we're going to get into in greater detail later on in the year. You'll notice that there are no SI units given for area and volume. Why is that? Well, to find area, it's length times width, right? Which would be, I don't know, a meter times a meter, which would be meters squared. Area and volume and other units like that are what we call derived units because they are derived, they come from other SI units. Here are some prefixes for the metric system we're going to use later on. And I also have another prefix table posted for you that we'll talk about more when we get to dimensional analysis. But Sig Figs. Sig Figs are important things. So when you take a measurement, there are a certain number of digits within a number that are significant or important to them. And there are rules to follow to know how many Sig Figs are in a number. So the first rule for counting Sig Figs, zeros that represent an extra level of precision are significant. So if I wrote 5, and then I added a decimal and added a 0 and a 0, those zeros show precision because it's not just 5, it's 5.00. So you're that much closer to the actual answer. And both those zeros would be significant because they're showing an extra level of precision. Captive zeros are going to be important. So if I had like 1001, those zeros are significant. Zeros that are merely placeholders are not significant. What that means, if I have the number 10,000, I can easily turn that into scientific notation. What is that? 1, 2, 3 to the 4th without getting rid of the Sig Fig. So in this one, there's only one Sig Fig in that number, and all those zeros are just placeholders. If you do need help with scientific notation, go back to the presentation page and there will be a video or a link for you to look at to go over scientific notation. And finally, all non-zero digits are significant. Okay, so if it's not a 0, it's an important number. Now, no one likes to just remember the individual rules, so there is one rule that encompasses all of them. It's called the Atlantic Pacific rule. So if there is a decimal absent, what you do is you start from the Atlantic, or that is the right side of the country, so the right side of the number. What we do is we skip over any zeros until we come to our first non-zero number. That number and every number after it is significant. So if we look at the first set of numbers here in the example, 200, decimal absent, I start from the Atlantic or the right side. I can skip over those zeros until I get to my first whole number. That number and every number after it's significant. So this one is just one sig fig. 700,000, same thing, no decimal. I can cross out those zeros. That's 7, and everything after is significant, so that's just 1. No decimal here. Start at the right hand, no zeros. That's my first whole number. That number and every number after it is significant, so this one gives me 4. 6,100. Start on the right side, skip over any zero until you get to your first whole number. That number and every number after it's significant, which gives me 2. 371,050. Start from, again, the right side, skip over any zero until you get to your first whole number. That number and every number after it will be significant, which will give me 5. Pretty simple. If there is a decimal present, you're going to start from the Pacific, which is going to be the left side of the number. Skip over any zeros until you come to your first whole number, your non-zero number. That number and every number after it will be significant. So we have 200 with a decimal. Okay, there's a decimal there. Start from the left side, no numbers to skip over, and my first number is a whole number. That number and every number after it's significant, which gives me 3. 200.0, again, that's my first whole number and everything after it. That's going to give me 4. Okay, so there's a decimal present. Start from the Pacific or the left side. Skip over any zero until you get to your first whole number. That number and every number after it's significant, so that's going to give me 1. Okay, same thing. Skip over those zeros, and that's going to give me 3. And then finally, there's a decimal present, no zeros. That's my first whole number. That number and every number after it is significant, which ends up giving me 7 sig figs. Now that's pretty simple. Sig figs themselves are not difficult. What is difficult, or at least more difficult, is talking about sig figs in calculations. So when we're talking about sig figs with calculations, we need to look at multiplication and division versus addition and subtraction. When multiplying or dividing, the final answer will have the least number of significant figures. So here I've got all multiplication and division problems. So what I'm going to do is I'm going to go through and see how many sig figs each one of these numbers has. This, 3 sig figs. 2.10, 3 sig figs. 0.75, that's 2 sig figs. My final answer is going to need 2 sig figs because that's the least number of significant figures. So all you would do, plot this into your calculator. This is the space where you're supposed to do that. You could pause next time. I'm not going to do a little space. So when you do that, you plop it into your calculator. You're going to get 4.80375. We obviously do not want all of those numbers as our answer. I need 2 sig figs. So 2 sig figs is going to give me 4.8. Can that zero round that 8 up? No, it cannot. So my answer is going to be 4.8. And we had just talked about we need units. Since it's meter times meter times meter, it's going to be meter cubed. All right. And so now for the next one, 1.75 times 250,000. 1.75 has 3 sig figs. 250,000 has 2 sig figs. Pop that into your calculator, you get 437,500. Okay. I need 2 sig figs. That one has 4. So what I'm going to do, this would give me 2 sig figs. That 7 will round that 3 up to a 4. Everything after it becomes a 0. I can't take 437,500 and round it to 44. I have to round it to 440,000. I need to keep it compatible, like close. And then we got 170 with a decimal. So since it has a decimal, that's going to be 3 sig figs. 0.00035 has 2 sig figs. And so put that in your calculator. You get a long answer, 485,714.2857. Okay, I need to round that to 2 Sig Figs. That 5, going to round that 8 to a 9, so 4, 9, and then everything else becomes a 0. 1, 2, 3, 4. And I don't even worry about the decimal anymore. It's not important to me. Or I could turn this into scientific notation, 4.9 times 10 to the 5th. Okay, it does not matter what you put your answer in. This number has 2 Sig Figs, that number has 2 Sig Figs, and that is the important part. By the way, when we talk about conversions, you do not count Sig Figs with conversions, and I'll show you what that means when we get there. Okay, adding and subtracting. When you add and subtract, you're looking at the least number of decimal places. So it doesn't matter what the whole number is. It could be a billion numbers long. All we care about is how many decimal places do I go. So what I would do with this, here's my problem. This is 2 decimal places. That's 1, that's 3. My final answer, regardless of what my whole number is, my decimal should be 1 place. I put this in my calculator, I do the addition, it gives me 56.572. So with my Sig Figs, I'm going to have 1 decimal place. My answer will be 56.6. 1 decimal place. Okay, 9.63, that's 2 decimal places. That's no decimal place, but there is a decimal that is important. This is 3 decimal places. I do this math. It comes out to be 385. And so my final answer, since there was a decimal in this number, I needed to include the decimal. Okay. Same in the next one, 339. There are no decimal places, but there is a decimal. This one has 3. I need no decimal place, but I do need a decimal. So it comes out to be 200.325. And then with Sig Figs, it's 200 with the decimal. And then finally, two decimal places, 1 decimal place. My final answer is 17.3 for that one. Okay. So again, looking for at least number of places after the decimal. That's it for Sig Figs. There is extra practice, and of course, there's extra resources on the presentation page if you feel like you need more. Again, you can just ask me any questions that you have, and I'll be happy to go over it. Again, the good thing about an online class, you've got the video, you can pause it, you can rewind, and you can go over it again. Now, dimensional analysis is something that you may or may not have been exposed to in the past, but it's a way of converting from one unit to the other. A lot of you have done conversions with, the metric system by swinging the decimal. We are not going to do that, okay? We are going to start with doing a couple of problems here with the metric system, but we're going to follow the dimensional analysis. Now, what I said earlier, that Sig Figs don't count for conversion problems, what you start with is what you end with. So in this practice problem, I have 1 Sig Fig. My final answer needs to be 1 Sig Fig. Okay. So when we're doing dimensional analysis, the first thing that you want to do, you're going to start with what you're given. That's important. So in this case, I'm given 5 kilometers, so km, and then put it over 1. What does it do? What does putting it over 1 do? It just is a placeholder, really. So step 2, we're going to do a multiplication sign in another line. And the second thing really is that units must cancel out, comma, so they will if the units are on the top and bottom. So if you've got something on the top and something on the bottom, they're going to end up canceling. So I have kilometers on the top. I need kilometers down there. Those things will end up canceling. And it's very important. You always go to the base unit, okay? So kilo is a prefix. Milli is a prefix. But the base unit for kilometer and millimeter is the meter, okay? And you can see all of those things on the prefixes that are uploaded for this presentation, okay? And if you need help with that, you have to know those prefixes. It's really going to be from 1,000 high and 1,000 low. Those are the ones that we're going to use most often. And then once you're at the base, I'm going to put 3 up here. From the base unit, you can go to any prefix you want, okay? So I'm going to go from the meter, so I'm going to put meters on the bottom, to I want to go to millimeters, okay? Now we have to plug in our numbers, and this is where knowing what your units, your prefixes mean. So the easiest way I like to think about this, okay, which one's bigger, a meter or a kilometer? And to tell on your prefixes, which one's higher up on that list. The higher one on that list is going to be bigger. So the kilometer's bigger, so put a 1 in front of the kilometer, and then ask yourself, how many meters are in a kilometer? So kilo means 1,000. So there are 1,000 of the smaller things in the bigger thing. Then we go over to the next one, meter versus millimeter. How many, well, which one's bigger? The meter is bigger. Milli means 1,000. So like if you did not know, a millipede is supposedly have 1,000 legs, okay? So we cancel out kilometers, we can cancel out meters, and I'm left with millimeters, which is the unit that it's asking me for. And then I can just go ahead and put this one in my calculator. It's very simple, so you really shouldn't have to. It's 5 million, all right? So 3, 6 zeros, 5 with 6 zeros. And then, of course, we need our units of millimeters. Okay. And then we had 1 sig fig. That answer has 1 sig fig. And you could, of course, put it into scientific notation if you'd like. Okay, I'm just going to erase this here so that I can do the next problem. I'm going to leave up here the part where it says always go to the base unit. So that is super important. If you don't go to the base unit, you cannot do anything else. So I'm going to start with 1,000, and that symbol is micrograms. This one's higher than 1,000, but it's okay. You have that prefix sheet in front of you. So that's micrograms. Again, going to the base. So from micrograms, I go to grams, which is the base. I don't want that, so I need to keep going. And then from grams on top, grams on bottom, because what's on top will cancel out with what's on bottom. I'm going to go to kilograms. Okay. Ask yourself which thing's bigger, a gram or a microgram. Even if you don't know, the word micro would probably imply to you that it's smaller. So I'm going to put a 1 in front of the thing that's bigger. And if you look at your prefixes, it's a million. So 1 times 10 to the 6th. Which one's bigger, a gram or a kilogram? A kilogram is. And then we know there are 1,000 grams in a kilogram. This math is actually really easy, and we really want to practice not just putting everything into our calculator. So if units can cancel what's on top, what's on bottom, so can numbers. This 1,000 on the top can cancel out with this 1,000 on the bottom, okay? So they can go away. So my answer is 1 over 1 times 10 to the 6th, which is 1 times 10 to the negative 6th. And of course, my units are kilograms. And that's my answer. That's dimensional analysis. So this would be a good place for you to pause and go and try to do some of the practice problems on the homework before we go to a little more complicated practice problems here in the notes. This problem here, these problems are a bit different because we're going to now have something in the bottom. So those problems all had a 1 at the bottom with no unit. If we look at this next problem, it says a leaky faucet is dripping at a rate of 0.05 milliliters per second. When you hear per, you should think of a slash, like miles per hour. That means whatever's after the per is going to be on the bottom. It wants to know how many gallons of water in 1 hour. Okay, so we're going to start with what we're given, 0.050 milliliters per 1 hour. Now, it does not matter which thing you do first, if you go from milliliters to gallons or hours to, oh, no, that should be seconds on the bottom, sorry. We want hours at the end. Okay, so if we think about planning this out, we have milliliters, we want gallons. Think about, do you know how many milliliters are in a gallon? No, but you have a clue here. So any conversions that you're not expected to know will be given to you. I would not expect that you know how many liters are in a gallon. So, but that is going to be our bridge to get from milliliters to gallons. We're going to go from milliliters to liters to gallons. Seconds are easier, seconds to minutes to hours. That one's, you should be aware of that one. And it does not matter which one you start with, the top unit or the bottom unit. We'll go ahead, I'll just do the milliliters. We'll put milliliters on the bottom to cancel out with milliliters on the top, and I'll put the liters there. I'm not done with that part because I want liters on the bottom, gallons on top, great. And I like to do all of the units first and then go back and put in my numbers. Now I'm not finished, so I'm just going to keep going. I'm going to do another step, but this time seconds go on top to cancel out with the seconds on bottom, to minutes, and then minutes to hours. Wonderful. And then you can go back and plug in numbers. Liters and milliliters, which one's bigger? The liter's bigger, put a 1 in front of it. Prefix milli means 1,000. Okay, and then I know this conversion was given to me. Okay, and then we can go from seconds to minutes. A minute's bigger, there are 60 seconds in a minute. An hour's bigger, there are 60 minutes in an hour. Okay, so now what you do is you put this in your calculator. The easiest way to do this, if you're not familiar, is with parentheses. So what I would put in my calculator if I was you and I had a graphing calculator. So parentheses 0.050 times 60 times 60, close that, division sign, parentheses 1,000 times 3.785, close that parentheses. Okay. If you want to multiply everything on the top, write that answer down, multiply everything on the bottom, write that answer down, and then do that division, that's fine too. Whatever you need to do so that you make sure you get the right answer, which of course is 0.048 gallons per hour. When you are finished with a problem, you want to ask yourself 3 things. Is the answer itself correct? Are the units correct? Do I have the right number of Sig Figs? So I did this math, so it's going to be correct. The units are correct. We want gallons per hour. We've got them. And then the Sig Figs, I started with 2 Sig Figs here. I'm ending with 2 Sig Figs here. So it's perfect. Okay, we go ahead and erase this part so we can do the next problem. And I like to map out my problems, especially if I'm just starting doing this, to write out where I'm going, what I'm starting with, and where I'm going. So the next one says the world record for the 100, and nope, there's a decimal there, so that has 3 Sig Figs, is roughly 9.58 seconds. If you ran 100 meters in 9.58 seconds, what would be your average speed in units of miles per hour? So we're going from meters per second. We want to go to, what is it, miles per hour. I'm not going to do the seconds to hours because you should be able to do that even before we came into this class, but we're going to do the meters to seconds because meters to miles, because there might be some things in there that you aren't aware of. And there's one conversion that's very helpful that if you don't know, you're going to want to know. So I'm going to take meters, which is my base unit, so I can go to anything and go to the centimeter, and then from centimeters to inches. This is the one that's important for this problem, but you might not know that conversion. So 1 inch equals 2.54 centimeters. Okay, and that's going to be the thing. That conversion is important because it's going to be able to convert from a metric to a English unit, the ones that we use. And then we can go inches to feet, and then we can do feet to miles. That one's easy. So I'm going to start with what I'm given. And I'm given 100 decimal meters per 9.58 seconds. I might have to erase that stuff at the bottom. And so we're going to go from meters to centimeters, centimeters to inches, inches to feet, feet to miles, which you may or may not know. If you don't, you should write that one down. And then you can see meters cancel, centimeters cancel, inches cancel, feet cancel. We're left with miles. And then I can just keep going and go from seconds to minutes, and then minutes to hours. And now I can go in and put in all my numbers. Meter, centimeter, the meter's bigger, put a 1 in front of the thing that's bigger. Centi, like century, it's 100. And then 1 inch is 2.54 centimeters. I told you that one. A foot is 12 inches. You should know that one. A mile is 5,280 feet. And then 60 seconds in a minute, 60 minutes in 1 hour. Put that all in your calculator. Multiply everything on the top by each other, write that down. Multiply everything on the bottom, write that down. Divide those two numbers, or in parentheses, multiply everything on the top, close that parentheses, divide by new parentheses, multiply everything on the bottom, close that, put an enter. The answer is going to be 23.4 miles per hour. Both of those numbers there had 3 sig figs. This has 3 sig figs. Okay, so that's correct. I've got my unit. So that is your answer. So the world record, when I made this like 8 years ago, so this is probably very outdated, was 23.4 miles per hour. So that's pretty fast. Okay, we've got one more practice problem here. Very similar to the last one. And then that's it for this note video. So a police officer pulls you over on 95, where the speed limit is 65 miles per hour. You inform the officer that you are actually traveling at a speed of 28,000 millimeters per second. Were you speeding? You may or may not be speeding, but you're a real jerk for sure. So you can do this 2 ways. You can take the 65 miles per hour and turn it into millimeters per second and compare it that way, or you can take the millimeters per second and turn it into miles per hour. Whichever way you want, the final answer of were you speeding should be the same. But I'm going to take the speed limit and turn it into millimeters per second. So I'm going to have 65 miles per hour, 1 hour. Okay. Now we just basically did a miles to, what was it? Miles to meters, meters to miles. So I just have one more step after that. So I'm just going to work backwards and go miles to feet, feet to inches, inches to centimeters. Centimeters, now I'm at the metric. I have to go to the base unit, meters. Meters to millimeters. And I'm going to have to go down here because I just don't have any room. Hour needs to go on top to cancel out with the hours on the bottom. Hours to minutes. Minutes to seconds. So seconds are in the bottom. Miles cancel. Feet cancel. Inches cancel. Centimeters cancel. Meters cancel. So I will have millimeters per second at the end of this. Now just go back and fill in all my conversion. 1 mile, again, 5,280 feet. 12 inches in a foot. 2.54 centimeters in an inch. 100 centimeters in a meter. 1,000 millimeters in a meter. 60 minutes in an hour. 60 seconds in a minute. Okay, so all of those should be correct. And then you just plug it into your calculator. Now I have 65 miles per hour, so that's going to be 2 Sig Figs. When I do this, I get an answer 29057.6, which if I have 2 Sig Figs is 29,000 millimeters per second. So that is the speed limit. So he says that I was traveling at 28,000 millimeters per second, not miles per hour, 28,000 millimeters per second. So I was not speeding. Okay. That is it for this video. Like I said, if you have any questions, please make sure you ask them. This is why I'm here. I know this is a lot different than what everyone's used to. It's a lot different than what I'm used to. So please make sure you ask your questions if you have them. All right, and I will see you in the next video.